Good day everyone, this is May Artubilia, and in this video I am going to discuss about fixed value measuring tools. And the tools or measuring tools featured in this video are slip gauges or gauge blocks and the go-no-go gauges. So just a little bit recap as what our instructor said in our previous lesson. Fixed value measuring tools are tools that have a predetermined value which cannot be changed or cannot be adjusted. So that's why it is called fixed value kay naanay value daan. Let's first have the motivation. So as you can see, there are 5 different pictures. From A to E, which of the following pictures do you think are slip gauges and go-no-go gauges? So just choose 2 pictures, one for slip gauges or gauge blocks and one for go-no-go gauges. So let's find out which of the following pictures is a slip gauge and a go-no-go gauges. So what you can see in this presentation are the correct answers. So this one is slip gauge and this is the go-no-go gauges. Actually, all these pictures are fixed value measuring tools. If you can remember, these 3 have been discussed by the other reporter before. So this is the filler gauge, a radius gauge, and wire gauge. So let's now have the learning objectives. At the end of this lecture, you should be able to define slip and go-no-go gauges, understand the uses of slip gauges and ringing, calculate workpiece angle using gauge blocks with the conjunction of sine bar, and know how to select gauge blocks for use in combinations. Understand the purpose of and difference between go and no-go gauges, and differentiate among the types of go-no-go gauges. So let's first define what is a gauge. A gauge or gauge in science and engineering is a device used to make measurements or in order to display certain dimensional information. Gauges are inspection tools of rigid design without a scale which serve to check the dimensions of manufactured parts. So, gauges do not indicate the actual value of the inspected dimension on the work. They can only be used for determining as to whether the inspected parts are made within the specified limits. Gauges can be classified according to their type. So, kaning sa type of gauges, we have a standard gauges that are made to the basic size of the part to be tested and have the measuring member equal in size to the mean permissible dimension of the part to be checked. And limit gauges, these are made to the limit sizes of the work to be measured. So the function of limit gauges is to determine whether the actual dimensions of the work are within or outside the specified limits. Second, according to their purposes. Either pang workshop ba siya or working gauges that are used at the bench or machine engaging the work as it being made, or pang inspect nga gauge ba na siya like inspecting a manufactured parts, or gauges that are used for reference or also called master gauges for checking the size or condition of other gauges. Third, according to the form of the tested surface, like plug gauges for checking holes or snap and ring gauges for checking shafts. Fourth, according to their design, like single limit and double limit gauges, single-ended and double-ended gauges, and fixed and adjustable gauges. So now let's tackle about slip gauge, its history, uses, and so on. Let's first know the history of slip gauge kung kinsay ga-invent or naka-discover ani nga gauge. Nganong na-invent ni or unsa joy purpose ani. So, Carl Edvard Johansson, a Swedish machinist, first introduced the slip gauges in 1896. So, they can be called as Johansson gauges as well. So, as you can see, this is Mr. Carl Edvard Johansson. Johansson worked for a rifle manufacturer at Carl Gustaf Stad's rifle factory in his hometown of Eskilstuna. So, Eskilstuna is in Sweden, as an armory inspector involved with Remington rifle manufacturing. So, this picture shows Mr. Johansson at the rifle factory. So, this is Mr. Johansson at the leftmost in the front row. So, according to Johansson's records, variously shaped gauges and a large number of limit gauges used on the shop floor were collectively referred to as gauge blocks. By the way, kaning shop floor is part ni siyas workshop or factory. So the top-end reference at the factory in those days was the micrometer made by Brown and Sharp Corporation, with which the shop floor gauges were measured and calibrated. Nowadays, micrometers are calibrated with gauge blocks. So, usa po ni sa uses sa slip gauges or gauge blocks and ang pag-calibrate sa micrometers. So, we are going to discuss that later on. So, sa wala pa na-invent ang slip gauges, the limit gauges are used for inspecting rifle parts, were manufactured specifically for each part and required remanufacturing every time a model was renewed or any part modified. When Johansson visited the Mauser Corporation in Germany, famous for the Mauser carbine, he was disappointed to discover that the factory used several thousand limit gauges. Therefore, Johansson thought about combining a minimum number of gauges based on the idea of how to test more dimensions with fewer gauges. So, after taking great pains, Johansson came up with a combination of 102 blocks that provided about 20,000 different dimensions from 1 mm to 201 mm in increments of 0.01 mm. He named this his combination gauge block set, which comprised 49 gauge blocks of 1.01 mm to 1.49 mm in increments of 0.01 mm, 49 blocks of 0.5 mm to 24.5 mm in increments of 0.5 mm, and 4 blocks of 25, 50, 75, and 100 mm. So, Mr. Johansson came up with a 102 blocks. Actually, sa full detailed history ani, naadan paning blocks ni Mr. Johansson og usa, which is the 1.005 mm block. So, 103 pieces na nga blocks. And then, in 1909, naadan na pud og 9 blocks. In total of 112 blocks. And napatoy mga challenges faced by him. But anyways, dili rata mo dig deeper sa history as long as the important points are mentioned. And ang atong gamiton pod sa pag-combine sa gauge blocks here kay katulang 83-piece set of English gauge blocks and 88-piece set of metric gauge blocks. So the first picture shows Mr. Johansson and his gauge blocks. And the other one shows or illustrates demonstration of gauge block ringing force performed by Johansson in 1917 at a mechanical engineering conference in Stockholm. So you can see two gauge blocks being rung together or stacked, meaning gitapot ang two gauge block for combination, and we will discuss later kung giunsa pag-combine. And we can also observe nga naay thing nga gibutang sa ubos. So this is more than 90 kilograms of weights were suspended from the lower gauge block. So imagine kung unsa ka bugat ang gamit para i-test ang combined blocks if matangtang or mabulag ba sila. But still, nag-stick Japon sila to each other. So, that's the brief history of slip gauges. And now, let's know or define of what really is a slip gauge or gauge blocks. Slip gauges are known as gauge blocks. They are precise measuring instruments. These slip gauges are universally accepted and standard of length. So, slip gauges is an end kind of length standard or an end standard of length. Actually, there are two kinds of length standard. The line standards and kaning end standards. Kaning line standards, ang example ani kay katong steel rule. A steel rule is a precisely graduated standard scale. And kaning end standard, example kay kaning gauge blocks or slip gauges that are used with contact methods of comparison, and gauge blocks are measuring phase-based standards. Slip gauges are cuboidal-shaped blocks of high-grade steel with a high finish. They are mainly used as measuring standards in the engineering field. A gauge block has two opposing sides, and these are called measuring faces. Finished precisely flat and parallel by grinding and lapping, so that the actual distance between these two faces is exceedingly close to the nominal size marked on the block. So, uses of slip gauge. Setting up a comparator to a specific dimension. It is used for direct precise measuring purpose. Used to inspect the vernier caliper, micrometers, and some other linear measuring instruments. Used for conjunction with sign bar to measure the angle of the workpiece. And used to check the distance between the parallel faces. So, slip gauges are classified according to their guaranteed accuracy. So, they are classified as AA for master slip gauges, A for reference slip gauges, or B for working slip gauges. So, the type AA slip gauges are accurate to plus or minus 2 microns per meter. The type A or the type single A is guaranteed accurate up to plus or minus 4 microns per meter, while the type B is 4 plus or minus 8 microns per meter. So, slip gauges could also be designed in 5 grades, or there are also different grades or classes of slip gauges. First, we have grade 2. So, this is a workshop grade. Typical uses include setting tools, cutters, and checking dimensions roughly or checking mechanical widths. Second, we have the grade 1. This is used for precise work in tool rooms and also used in setting up sign bars and sign tables, checking gap gauges, and setting dial test indicators to 0. Third, grade 0. This is used as inspection grade of slip gauges, mainly by inspection department. So, meaning, the inspection department lang ang naay access aning grade. And in this way, it is not possible for these slip gauges nga ma-damage or abused by the rough usage like sa paggamit sa shop floor. And fourth, we have the grade 00, which is mainly used in high precision works in the form of error detection in instruments. Lastly, the calibration grade. This is a special grade with the actual size of the slip stated or calibrated on a chart supplied by the manufacturers. So we have here an example of gauge block nomenclature. So we can see here a stack of gauge blocks. Stack means the rung together combination, and combination refers to a group of blocks that form a desired size when rung together. So this is a combined blocks in different series. Series means all the blocks of one basic size. So for example, naatay thin block, a blocks in 0.100 inch or thinner series combined with the other series kani, the long block or any block longer than 4 inches. So the two blocks with different series are combined to build a stack by ringing. So ringing or ring or rung refers by placing blocks in intimate contact. So the reference surfaces adhere. So later on, we are going to discuss kung unsaon pag-ring or ato i-discuss later ang ringing process. Ringing interval, separation between rung surfaces, and film, air of liquid separating rung surfaces. So in a stack of gauge blocks, we can observe nga naay laing block. So this is called wear block. So blocks reserved for use in reference surfaces. So wear blocks can also be called as protector slips. The purpose of wear blocks are to prolong the life of slip gauges or gauge blocks. So there are some sets of gauge blocks that contains two wear blocks. So these two wear blocks are placed at each end of the assembled blocks to ensure that any wear or damage is confined to these two blocks. So for example, we have this inspected micrometer with the stack of gauge blocks. So as we can observe, naay wear block in each side or in each end to prevent wear or damage in the other blocks or to provide wear resistance and longer the life of gauge blocks. The wear blocks should always be on the outside of combination. And take note that the length of the wear blocks must include in the desired length of the combination. Meaning, ang length size sa wear blocks kay apil na siya sa total length sa combined blocks. Iyang length size kay counted sa total or desired length combination. So now let's have the ringing process of slip gauges. Again, ringing refers to joining by sliding truly flat faces one on another. So due to adhesion property of slip gauges, they will stick together. This is because of very high degree of surface finish of the measuring faces. So this is the ringing process. So first, before using slip gauges, the faces should be cleaned. Second, slide the one slip gauge over the other with little pressure. This way, we can expel the air between the slip gauges faces. So just observe the picture or the illustration. Third, once place the one gauge 90 degrees to another gauge by using little pressure. Then rotate it by clockwise to make them in line. Fourth, ringing helps to achieve a dimension by summation of the individual size of slip gauge. The need of clamping is also avoided. Now, we have here sets of gauge blocks. So, this is the set of English gauge blocks which contains 83 pieces of blocks, including the 2 word blocks. So, in the first box or first group of blocks with a 0.001 divisions, this contains 9 blocks from 0.1001 inch to 0.1009 inch. On the second group with 0.001 inch divisions, this contains 49 blocks from 0.101 inch to 0.149 inch. On the third group with a 0.05 inch divisions, this contains 19 blocks from 0.050 inch to 0.950 inch. And on the fourth group with 1 inch divisions, this contains 4 blocks from 1 inch to 4 inches. And the 2 were blocks which both have the same length, which is 0.050 inch. And we also have here the 88-piece set of metric gauge blocks, also including the 2 were blocks. So on the first group of blocks with 0.01 millimeter divisions, this contains 9 blocks from 1.001 to 1.009. On the second box or group of blocks with 0.01 millimeter divisions, this contains 49 blocks from 1.01 to 1.49. And on the third group or box with 0.5 millimeter divisions, this contains 19 blocks from 0.5 to 9.5. And on the fourth group of blocks with 1 centimeter divisions or 10 millimeter divisions, this contains 9 blocks from 10 to 90. And also we also have here the 2 were blocks which both have the same length, which is 2 millimeter. How to select gauge blocks for use in combinations. So gauge block selection is a process that starts by examining the last or smallest decimal place of the desired combination and eliminating it while subtracting it from the remaining length of the desired combination as you proceed. The process is repeated for each remaining decimal place until the total combination has been selected. So for example, using the 83-piece set of English gauge block, a desired combination is to have a length of 3.9762 inches. So the first thing to do is to subtract the total length from the size of 2 were blocks. So atong subtrakan ang total length, which is 3.9762 inches sa 2 were blocks. So ang length sa kada were block is 0.050 inch. So 3.9762 minus 0.050, the first were block, is equals to 3.9262 minus 0.050, the second were block, equals to 3.8762. Now, ang sunod natong buhaton is to eliminate ang fourth or decimal place. So, atong i-eliminate ning 2. So, look over the available blocks in the set for a block that has a 2 in the fourth decimal place. So, ato tas a set of blocks. Mangita tag block diri nga group with 4 decimal place. So, atong pangitaon ang pwede nga block para ma-eliminate ang 2. So, we have the 0.1002 inch. Then subtract the selected block from the total length of the desired combination that is being subtracted by the two word blocks to eliminate the last decimal place. So atong i-subtract ang remaining length kaganina nga 3.8762 sa first selected block, which is 0.1002 is equals to 3.776. So the last or the fourth decimal number have been eliminated. So now, examine the next smallest decimal place. So in this example, it ends with a 6. So find the blocks in the set that have a 6 in the third decimal place. Choose the block that will leave either a 0 or a 5 in the second decimal place when you subtract this block from the result in step 3. So, dapat ang atong piliun nga block is to eliminate na pud ning third decimal place or the last decimal place, which is the 6. And that will also leave the 7 either a 0 or 5. So, ato ta set of blocks. So, we are going to find the block that have a 6 in the third decimal place. So, as we can see, there's a row of blocks in which in each block ends with 6 in the third decimal place. So, na ay 5 blocks. But we have to choose the block that will leave either a 0 or a 5 in the second decimal place, which is 7 when you subtract this block from the result. So we are going to choose the block 0.126. Then subtract the selected block from the result in step 3. So 3.776, the remaining length, or the result in step 3, minus our second selected block, which is 0.126, is equals to 3.65. So, the block was chosen so that the result in this decimal place was either 0 or 5. So, as we can see, the number, the third decimal place or the number 6 had been eliminated, which leave the second decimal place a 5. So the selection is about done. It can be seen from the remainder in step 5 that a 0.650 and 3 inches block will complete the combination. So ang atong remaining length kaganina is 3.65. So we are going to choose a block nga will eliminate the decimal places or the 0.65. So sa atong sets, ang na dito kay 0.650. Ang 0.650 o 0.65 are just the same. So 3.65 minus the third block, 0.650 is equals to 3 inches. Minus 3 inches is equal to 0. Sa atong fourth block is the 3 inches. So, double check the combinations by adding together all the selected blocks. So, atong i-add tanang blocks or gauge blocks nga that is being selected. So, 0.050 plus 0.050, these are our two were blocks, plus 0.1002, the first block, plus 0.126, our second selected block, plus 0.650, our third selected block, and plus 3 inches, our fourth selected block, is equals to 3.9762. So, maunig atong total length of desired combination. So, meaning, we have selected the correct blocks that will have a total length of 3.9762 inches when combined. So, now, let's have another example using the 88P set of metric gauge blocks. So, this is performed in the same manner. So, a desired combination length of 50.932 millimeter. So first, subtract the total length from the size of two were blocks. So, ang length size sa were blocks using the metric is 2 millimeter. So, 50.932 minus 2 is equals to 48.932. Then, minus na po na to siya sa second were block, which is 2 is equals to 46.932. So again, the next thing to do is to eliminate the third or the last decimal number. So in this case, we have 2. So examine the blocks in the set that have a 2 in the third or lowest decimal point. So let's check sa set of metric gauge block. So, ang atong i-select nga block is to eliminate the third decimal place, which is 2. So, we have here the 1.002. So, subtract the chosen block from the size of the desired combination that is being subtracted with 2 were blocks. So, 46.932 ang atong remaining length minus sa our selected block, which is 1.002, is equals to 45.93. So, the third decimal number or the 2 had been eliminated. So, now choose a block to eliminate the next smallest non-zero decimal point. Choose a block that will leave either a 0 or a 5 in this decimal place. So, again, we are going to eliminate the second decimal place or the last decimal place or number within the remaining length, which is 45.93. So, atong i-eliminate ning 3, which will leave the 9 either a 0 or a 5. So, let's go back sa atong set sa metric gauge block. So, we are going to find 3 sa last decimal place or second decimal place. So, nadre one row with 5 blocks that ends in second decimal place, which is 3. So, we are going to choose the block that will leave either a 0 or a 5 sa 9. So, we have a 1.43. So, subtract the chosen block from the remainder in step 3. So, ang atong remaining length is 45.93. So, minus our selected block, which is 1.43, is equal to 44.5. So, the second decimal number have been eliminated, which leaves the first or the 9 5. So, choose block to eliminate the next smallest non-zero decimal point. Choose a block that will eliminate the first whole millimeter decimal place as well. So, we are going to choose a block that will eliminate the 5 and that will also eliminate the first whole millimeter decimal place, which is the 4. So, let's go back sa atong set of metric gauge blocks. So, we have here the as a 4.5. So, subtract the chosen block from the remainder in step 5. So, 44.5 minus 4.5, our selected block, is equal to 40. So, as you can see, the 5 had been eliminated as well as the first whole millimeter, which is 4. So, now choose a block to equal the whole millimeters left in the combination. So, ang atong nabilin nga length is 40. So, atong lantawon diri sa atong set of gauge blocks kung unsay atong i-select nga block nga ma-0. I-minus nato para ma-0 na siya. So, we have here in 1 centimeter divisions or 10 millimeter divisions, we have 40. So, 40 minus 40 is equals to 0. So again, to verify that the combination of chosen blocks equals the desired length. So let's double check. So 2 plus 2. So mo ni gatong 2 were blocks plus 1.002 ang atong first selected block plus 1.43 our second selected block plus 4.5 our third selected block and plus 40 the fourth selected block is equals to 50.932. So mo ni atong total length of desired combination, which means we have selected the correct blocks that will have a total length of 50.932 when combined. So, let's practice. So, from the 83-piece set of English gauge blocks, build a stack for the following lengths. 2.5744 inches and 3.6688 inches. And from the 88-piece set of metric gauge blocks, build a stack for the following lengths: 43.716 mm and 58.975 mm. So just follow the procedure in selecting gauge blocks. So you can just post this video so that you will have enough time in answering the activity. So let's check your answers. So number 1, using the 83-piece set of English gauge blocks, build a stack for the length 2.5744 inches. So, una tong buhaton is to subtract it from the 2 were blocks. So, 2.5744 minus 0.050 is equals to 2.5244. Minus 0.050, the second were block, is equals to 2.4744. So, now, we are going to eliminate the fourth decimal place. So, our selected block will be 0.1004. So, 2.4744 minus 0.1004 is equals to 2.374. Then, 2.374 minus our second selected block, which is 0.124, is equals to 2.25. Now, 2.25 minus the third selected block, which is the 0.25, is equals to 2. Then, 2 minus na po nato sa fourth and last selected block 2, 0 the number. So, 2 minus 2 is equal to 0. So, again, to double check, just add all the selected blocks, including the 2 were blocks, to check if ang mugawas is ang desired length ba nga atong gipangita. So, 0.050 plus 0.050 ang atong 2 were blocks plus the first selected block 0.1004 plus the second selected block 0.124 plus the third selected block 0.25 plus the last or fourth selected block, which is 2, is equals to 2.5744. So, in number 2, again, using the 83 piece of English gauge blocks, build a stack that stack for the length 3.6688 inches. So, again, may nasa na po nato siya sa 2 were blocks, which is 0.050 is equals to 3.6188. Again, minus na po sa second were block. So, minus 0.050 is equal to 3.5688. Then, minus with the first selected block. So, ang atong selected block, first selected block is 0.1008 is equals to 3.468. Then, may nasa na po nato sa atong second selected block. So 3.468, the remaining length, minus our second selected block, which is 0.118, is equal to 3.35. Then, ang ato na pong i-eliminate is the 0.35. So, 3.35 minus the third selected block, which is 0.35, is equals to 3. So, 3 minus 3, our fourth selected block, that will result in 0. So, again, double check by adding them, adding all the selected blocks. So, number 3. So, using the 88-piece set of metric gauge blocks, build a stack for the length 43.716 millimeter. So, minus the total length with the two were blocks, that will result in 39.716. Then, eliminate the third decimal place, or the third decimal number, which is 6. So, our first chosen block is 1.006. So, 39.716, the remaining length, minus 1.006 is equal to 38.71. Then, we are going to eliminate the second decimal number, which is the 1, that will leave the first or the 7, either a 0 or 5. So, our second selected block will be 1.21. That will result in 37.5 when subtracted. So, now our remaining length is 37.5. So, 37.5, ato na pong i-eliminate ang first decimal place or number, which is the 5. That will also eliminate the the first whole number in millimeters. So, we have 7.5. So, 37.5 minus our third selected block, which is 7.5, is equal to 30. So, we are in the fourth, so atong remaining length is 30. So, we are going to subtract it with 30 millimeter, which is the fourth selected block, is equal to 0. So, again, double check if pag-plus ba nimo sa, or pag-add ba nimo sa tanan nga blocks will result in or equal in the desired length combination. So, which is 43.716. Now, for the last number, so again, still using the 88-piece set of metric blocks, build a stack for the length of 58.975 millimeters. So, again, subtract it with the two were blocks. So, 58.975 minus the two were blocks. So, minus 4 is equal to 54.975. And our first selected block will be 1.005. That will eliminate the third decimal number, or the last decimal number or place, which is 5. So, 54.975 minus 1.005 is equal to 53.97. Then, our second selected block is 1.47 to eliminate the second decimal number or place. That will also leave the 9, or the first decimal number, to 0, either 0 or 5. So, 53.97 minus 1.47 is equal to 52.5. So, the second decimal number have been eliminated. That leave the 9A 5. So, the third block is 2.5. So, 52.5, our remaining length, minus 2.5, the third selected block, is equal to 50. So, we now have the we have a 50, the remaining length size of block. So, minus 50, the fourth selected block, that will result in 0. So, double check by adding all the selected blocks including the two were blacks. Now let's have the slip gauges in combination with sine bar in finding or measuring the certain workpiece angle. So the illustration shows the combination of the two. So these are the blocks or stack of gauge blocks that serves as the height. This is the sine bar that will serve as the length. So by the way, ang sine bar is a precise angle measuring instrument. Then the workpiece being measured and the dial gauge that is used to check the parallelism of a surface. So this is the formula in finding the angle of a workpiece. So this symbol is the angle of the component to be measured. H is the height of the gauge blocks, and L for the length of the sine bar. So the formula is sine angle equals height of the gauge blocks divided by the length of the sine bar. So let's have an example. So we are going to find the angle with a given height of the gauge blocks 25.882 millimeter and the length of sine bar 100 millimeter. So these are the blocks selected to build a stack of blocks that will total of 25.882 millimeter. So our formula, sine angle equals height of the gauge blocks divided by the length of the sine bar. So it's equal to 25.882 divided by 100 is equal to 0.25882. And we are going to use the inverse sign. So that will total in 15 degrees. So ang atong angle is 15 degrees. So let me show you this application video.
So to do this, we're going to need a set of gauge blocks or slip gauges, and we're also going to need a tool called a sine bar. And the sine bar that we'll be using is a 100mm metric sine bar, and that's going to allow us to measure the angle. And the principle of this is that we're going to create a stack of slip gauges on the right hand side, incline it at an angle, and then the sine bar can be used either to scribe lines in layout or it can be used to inspect angles with a dial test indicator. So this is an image of what we're trying to achieve. We're trying to incline the sine bar at an angle of 15 degrees so that when we run the finger type DTI across the top of the surface, we can check for any movement, and this surface should be flat. So it's called a sine bar for good reason, because these points here are exactly 100mm. That's the hypotenuse of a triangle. The slip gauge stack is the opposite side, and we form a triangle there. So we need to apply a bit of secondary school or high school trig to find the exact height of slips required to create the 15 degree angle that we require. So you probably remember. So SOH, sine 15, equals the opposite, which is our slip gauge pile here that we don't know. We're trying to find that out, over the hypotenuse, which is this known distance, is 100mm sine bar, so that is 100mm. And we can rearrange that to get sine 15 times 100 is equal to the slip gauge height that we need. So we'll need to put that into a calculator. If you're not sure how I did that, if you're not too familiar with trigonometry, then you can just use a equation triangle here. If you're not so good with transposing equations, cover up the O and it's sine times h. If we needed to find the angle, it'd be the opposite divided by the hypotenuse. So let's chuck that into a calculator. There we have it. So we've got 15 sine times 100, and it gives us 25.8819. Our slips will measure to the thousandth, so we're going to use 25.882. 25.882mm. So what we need to do now is pull those out of the slip gauge pile, and to do that we'll start from the right. We'll have a 1.002, a 1.08, a 1.8, and 22 millimeters of other slips. Once we've chosen our slips, we need to ring them together, which means basically put them at 90 degrees and twist them with a little bit of pressure, and they'll stick together due to molecular attraction. Now, what I'm doing here is actually bad form. You shouldn't put them in contact with the surface plate and certainly not slide them like I did, but we're showing the point that they will stick together to create the accurate height. Once we've got the slip gauge pile, we can place that against an angle plate. That section, I guess, is unnecessary but helpful for getting everything squared up. Now I'm going to use 2 sine bars as opposed to one thick one. Don't have one single thick one, and we're going to support our sliding block on top of there. Now, if everything goes correctly, then we should create a flat surface there due to the two 15-degree angles. And what we'll do is we'll run a dial test indicator across that top surface so that we can check whether it's running out or not. If it doesn't run out, we'll get a reading of 0. So we need to line up our DTI so that the finger is roughly at an angle of 20 degrees or so when we first start. That way, when it makes contact with the block, it's near enough horizontal, and that's going to reduce sign error. Then we can move it back and forth. Once we're happy that it's in correct contact, we can zero out the gauge for a setting, run it back and forth once again, and make adjustments to the slip gauges on the right hand side so that it does actually run flat and true. So here we can see it's actually raising a little bit, so it's probably a little bit low at the bottom there, so we need to add slip gauges to reduce that error. So now we're faced with a situation where we know the opposite side, so perhaps we've adjusted that to 25.951, and that causes it to run flat, which means now we've knocked this angle out. So we're actually going to find out what this angle is here. So this is an unknown angle, and the convention is to call that unknown angle the Greek letter theta. Okay, so we're still going to use, in essence, the same type of equation, but this time we need to find the sine theta. So sine the unknown angle theta is equal to the opposite, which in this case is 25.951 divided by 100. So we need to process that, and to find out theta we're going to use the inverse sine of this, which should be 0.25951. Again, we'll put that in the calculator. 25.951 divided by 100. Sine to the minus 1, so inverse sine to the minus 1. So the angle that we've actually inspected there isn't 15 degrees, but 15.041, which is amazing considering with so little equipment we've managed to inspect to 1,000th of a degree.
Now, let's move to the second fixed value measuring tool, the go-no-go gauges. Go-no-go gauges are inspection tools used to determine if manufactured parts are within specified units. So, go-no-go gauges are limit gauges that are made to the limiting sizes of the work to be measured. As the name suggests, a go gauge intends to go inside the part feature, whereas no-go gauges not to go inside the part feature under consideration. So one gauge is made to the maximum and the other to the minimum permissible size. A go-no-go gauge is typically used in manufacturing settings to quickly check to see if an item is within the allowed tolerances. While it does not return an actual measurement, it does allow an operator to know whether something is acceptable or unacceptable. To utilize a go-no-go gauge, the operator must test a piece at both ends. An acceptable piece should pass the go test and fail the no-go test. So, for example, kaning color brown, mao ni atong piece or component nga i-check. So, sa go gauge, dapat mo go inside siya sa part feature. Dapat mo fit in siya sa component. And if ni-fit in siya, this means that the mating part does not have an excessive material. Whereas the no-go gauge, the gauge must not fit into the part or component, which means that this component is not lacking of material or it is not too large. In other words, the go gauge should accept the hole that is to be checked, whereas the no-go gauge should reject. So there are three conditions. So following these three conditions can arise while working go and no-go gauges. Either inspected part is accepted or rejected depending on these three conditions. In case 1, if the go gauge fits in the inspected part as well as the no-go gauge, then the part will be rejected. In case 2, if the go gauge fits in the inspected part and does not fit in no-go gauge, then the part is okay or accepted. And in the third case, if the go gauge does not fit in the inspected part, also the no-go gauge, then the part is rejected. So that are the three conditions. So there are different types of go-no-go gauges. These types are the plug gauges, ring gauges, and snap gauge, and each type has its corresponding kinds. And therein, plug gauge are double-ended, single-ended, flat type or shell form, progressive, thread, and taper plug gauges. In ring gauges, there are two kinds, the plain and thread ring gauges, while the snap gauge have only one kind, the adjustable caliper gauge. Plug gauges are used for checking holes of different shapes and sizes. Plug gauges are available for checking straight cylindrical holes, tapered, threaded, square, and splined holes. It is made of wear-resistant steel and hardened to not less than 750 HV. Plug gauges are available in different kinds according to the size of holes to be checked and also according to the nature of use. First, the double-ended plug gauge. The double-ended plug gauge is used to test the limits of size. So one side is go end and the other side is no go end. This is used for sizes up to 63 mm. And then the single-ended plug gauges. Single-ended plug gauges are used to test the nominal size of a cylindrical hole. In this type, two pieces are to be used. One piece has go end and the other piece has no go end. This is generally used for sizes over 63 mm and up to 100 mm. The other kind is the flat type or shell form plug gauge. This type is used for sizes over 100 mm and up to 250 mm. So two pieces are used, one go gauge and the other one is no-go gauges. This type is designed to reduce the weight of the gauge. Next is the progressive plug gauge. These plug gauges are used for checking the diameter of straight hole. So the go gauge checks the lower limit of the hole and the no-go gauge checks the upper limit. Then the thread plug gauges. The internal threads are checked with thread plug gauges of go and no-go variety, which employ the same principle as the cylindrical plug gauges. The thread plug gauges are used to check the form and dimensional accuracy of internal threads. And lastly, the taper plug gauge. This is the most satisfactory method of testing a taper is to use taper gauges. They are also used to check the diameter of taper at some point. Now, let's move to the other type of go-no-go gauges, which is the ring gauges. Ring gauges are used to check if manufactured pin or round fixture and external threads are within limits. There are two kinds of ring gauges, the plain and thread ring gauges. Plain ring gauge are used to set electronic bore gauges, air gauges, internal micrometers, and length measuring instruments. Plain gauges are ideal for gauging the outside diameter of parts, while the thread ring gauge is used to check the accuracy of an external thread, and they check the form and the dimensional accuracy of external threads. And the third type of go-no-go gauges is the snap gauge. Snap gauges are used for checking external dimensions. Shops are mainly checked for snap gauges. So, a ring gauge is also meant for checking the external dimension. However, at the central region of a shaft, if there is intentional change of diameter, it cannot be checked by ring gauge. So, that is why naaning snap gauge. So, adjustable caliper gauge is the other kind or form of snap gauge. These gauges are generally C-shaped and are adjustable to the maximum and minimum limits of the part being checked. So, when in use, the work should slide into the go anvil but not into the no-go anvil. Snap gauges are adjustable caliper gauges, can be used for checking external sizes in any place along the length of a work. So, how to use the go-no-go gauges? So, let me show you this application of go-no-go gauges.
Double-ended plug gauge. In this video, we are going to see about double-ended plug gauge. In this type, the go end and no go end are arranged on both the sides of the plug workpiece. No go. The no go end must not go into the component feature. Go. Go end of the gauge must go into the feature of the component being checked. The double-ended limit plug gauge is used to test the limits of size. This type has the advantage of easy handling. Single-ended plug gauge. In this video, we are going to see about single-ended plug gauge. Consider component go, no go, it is used to test the nominal size of a cylindrical hole. This is generally used for sizes over 63 mm and up to 100 mm. Progressive plug gauge. Let us see a 3D model of a progressive gauge. These plug gauges are used for checking the diameter of a straight hole. The go gauge checks the lower limit of the hole and the no gauge checks the upper limit. Thread gauge. Let us see a 3D model of a thread gauge. Internal threads are checked with thread plug gauges of go and no-go variety, which employ the same principle as the cylindrical plug gauges. Ring gauge. Let us see a 3D model of a ring gauge. Ring gauge. Workpiece. These are used to check the outside diameter of the workpieces. Separate gauges are used for checking go and no-go sizes. The no-go end must not go into this feature. Go end of the gauge must be go into the feature of the components being checked. Snap gauge. Let us see a 3D model of a snap gauge. Workpiece. Snap gauge, go and no go. Snap gauges are used as quick means for checking sizes within certain limits by comparing the size of the parts with the opening of the gauge. The no-go end must not go into this feature. Go end of the gauge must be go into the feature of the components being checked. Adjustable caliper gauge. In this video, we are going to see about adjustable caliper gauge. It consists of adjustable anvil, fixed anvil. Go, it is marked in green color. Place the slip gauge on the anvil. See the go and no-go standard with help of slip gauges for specified limits of size. The adjustable caliper gauge can be used for checking external sizes in any place along the length of a work.
So, what are the advantages and limitations of go-no-go gauges? So, advantages: simple and accurate, convenient and economical, no need to measure feature size to ensure parts are within limits, and easy to operate. Its limitations are verify parts for fitment only, cannot monitor gradual deviation in the manufacturing process, and recommended to be used on production parts. So that's all for my report. Thank you for watching.